Hey, people. All right. Any questions before we start? I have the chat box open, so if you guys want to type exact same, we're in the 13th lecture. I've said this the first 12 times, so I think the surprise will be minimal. Okay, let's get started. We're going to introduce the p-value today, the p word. It's almost a curse word in statistics now. And the idea of significance and what it actually means, how to interpret it, how to employ it like a honest, dignified person. It's really important, the p-value, but people misuse it a lot, and we'll talk about that. Just remember, we are not very far into the semester. We've done one exam so far, so we have 100 points. That's we're 20% of the way in, right? So we have 100 out of 500 points. That CD certification, if you go here, if you go to this link, either one of those links, if you go to those, that's 10 points. It's just, you just do it and pass. It's like impossible to fail. Somehow I have had people fail this before and be like, oh, professor, I didn't pass. But you can just hit the back arrow and retake the test right after it tells you what all the answers are to each individual quiz. And there's a ton of modules. You don't have to do it in one sitting. I used to time myself when I would do it, and I think I got the fastest I could do it was like 22 minutes or like 19 minutes or something like that. But the first time I did it, it took me like 10 hours. So I didn't know that you could just go back and retake the modules. And I was taking myself very seriously. How many times I encountered the Belmont report in that week. IRB forms, this will take a little bit longer, but these two documents, right, they're both up on Canvas. The zip is just if you want to be more comprehensive, and there's some more files in there. But these are the examples, right? You're not going to fill those in exactly. You told us to calculate a grade. We multiply a score by 2 without calculating Canvas. Canvas isn't going to. There's a question about grades. Well, we'll talk about grades later at the end if you want to talk about grades. But yeah, Canvas isn't gonna update it, but just multiply it by 2. Um, so again, we have one exam done, 100 points. The mean grade is in the 70s, but we have 80% left, right? The final exam is easy. Everyone does it in groups. That's 20 points. There's the poster. You do that in small groups. That's 100 points, just as many as this first test. The take-home test, that's 10 points. If it's take-home, everyone should get 10 out of 10. 4 labs, all take home. Everyone should get 10 out of 10. CD and IRB, those are each 10. And the executive summary, I'll talk about what this is today. So you can do all 3 of these like this week before the weekends, and it's Friday, and you could bang out all 3. The IRB will take a little bit longer. But so you have a ton of take-home points for the rest of the semester. And we talked a little bit about our exams, but let's just talk about the statistics of it again, because during this block, you're starting in on your labs, and you have to understand how to run stuff. Nathaniel will work a lot with you on where to click on SPSS. I will do that in class also, but it's going to be up to you to run those analyses yourself. And sometimes people just listen passively in lecture and not quite, kind of delve into the shallows of the lab assignment and information, and then struggle on the actual running of the analyses and like help at the last minute. But question, if the research question is for our poster, does that mean more than one person can have the same research question? The answer is yes. And 3 people, you can have 2 or 3 people in a group if you want. You can do it individually. I know many people every semester do their research project individually. They're sort of burdened by the idea of working in groups where one person does the project and the other people are piggybacking. And then sometimes people have a group figured out where they know how to allocate labor, and they can like respect each other to do that allocation. So it's up to you what you want to do. If you want to do by yourself or with two people or with three people, that's totally fine. If you do it with three people, you'll have those three people have the same research question. Now that said, if you do a project individually, the expectation is a tiny bit lower. If you do three people in a project and you do the exact same amount of work as one person did, I'm going to look at you with a furrowed brow. So if you get into groups, you're gonna want to do a little bit more work, right? You have three people to tackle the same workload. I'm going to expect that workload to be a little bit more impressive. So SPSS, there's a variable view and a data view, and in the variable view, you can code what type of variable you have. So scale, that right is going to be the ratio data, all that continuous interval ratio, that continuous data, that's going to be coded as scale. Nominal, you know what that is, it's political party, sex, whatever. Ordinal, that for this case it would be, in the alphabet, and nominal would be, sex or gender. And if you've had me before, that would be a nominal one. And then just, we went over this, but the descriptives are the basic, the first thing you do. It's SPSS, it's called descriptives, and either descriptives or frequencies. We didn't have too much in the way of frequencies. We could say, what percentage of the class is male or female? That would be frequencies. Descriptives are means and standard deviations and medians, stuff like that. Skewness, kurtosis. The correlations, you'll be doing a lot of bivariate correlations, and just looking at, do two variables move together? This was on the last test, we talked about it. And a Pearson correlation, well, this is the exact same, exam one score compared to exam one score compared to alphabet number. But alphabet number compared to alphabet number. So it's a table, so you ignore this diagonal row here. But if it's like you see something like, well, entering GPA and exam one score, those are both continuous. Your GPA can be 2.34987 or 3.5185 pi or something. And the exam one score is also continuous. And so that you're just going to get a Pearson correlation coefficient. It's going to be that thing. It's an R. You report it as R equals, like for the entering GPA, R equals 0.501, P equals, significance is P equals 0.005. Now, if it's something like sex, it's coded as 0 and 1, males and females. That would be a point biserial correlation is what you call that. You don't call it a Pearson correlation coefficient, although that's what it says. You call that a point biserial, where you have ratio or interval, right? So exam one score, entering GPA, something like that, correlated with a dichotomous variable, a binary, sex. And then phi or phi, phi, it's pronounced phi in Greek. But that's a correlation between two dichotomous. So if it was, let's say, political party where Republicans and Democrats, or progressive and conservative, or whatever, I guess it would be inverse of that. But so sex, male and female, versus political party, Democrats and Republicans, that you'd be getting into phi, phi. You can pronounce it phi, that's fine. And there's also like Kramer's V if you're going to do categorical variables, and there's more than binary, it's more than dichotomous. We'll talk about all that stuff later, but that is where you're getting a lot of this information. These basic correlations. Are variables correlated? Do they move in the same direction? That would be a positive correlation. There is no, the question is, where is phi or phi, phi on this table? And there isn't, because the only one we have is sex, is the only binary variable we have here. And so we're not seeing anything like that, but we do see point biserial. sex and exam one score, sex and GPA. So we do see point by serial, and then we see these Pearson correlation coefficients. A t-test, you will run a lot of t-tests in this class, and super easy to run, super easy to understand. This is the whole output of an independent samples t-test. We looked at males versus females, two independent samples are independent of each other. You're not male for part of the test and female for another part of the test, right? It's just your sexual assignment, right? Let's just sex as opposed to gender, right? So we're going to have a binary a chromosomal definition here, and so you have one assignment, and it didn't change, during the study training. Sociological and philosophical and psychological and ethical arguments could be made here. We're simplifying things and saying male and female. And so we have two independent groups. Now, the means and standard deviations, you would report that. So, 77.1 plus or minus 11.8, 76.7 plus or minus 15.6 for these two different groups. And then you would look at this value, and if you meet that, you meet the assumption of homoscedasticity, the assumption of equality of variances. I guess you could add people who identify as other. Right, yeah. So the question, if you could identify people, if we're going to do gender, then we could say there's several identifications, several classifications. What is your pronoun, and we could come up with different versions of that, and have we could get into something that's not binary, right? We could get into something that is going to be more Kramer's V oriented. I'm not going to make you run Kramer's V and stuff like that in the semester, just to understand that there's a little bit more environment. If you've been to Hollywood or something, or like Universal Studios or something, where they film movies, and then you see like, oh, this is where they filmed King Kong and Jaws and Harry Potter and whatever. And then you turn your head to the left, and it's just this weird warehouse. Right. That's what I don't want to introduce statistics in that way, where you turn your head to the left and there's nothing there. You turn your head to the right and there's nothing there. You have the blinders on, and all there is a Pearson correlation coefficient, as though it's a Hollywood set, and everything outside of that set, you just turn around and it's weird, like people wearing headphones, and there's no environment there. Statistics is this big, broad, all-encompassing environment, and I would be doing a disservice to this class if I set it up accordingly. If I didn't do in like fantasy literature world building, if I didn't build an appropriate world here, so that there's more to Middle Earth than the Shire, right? That there's every little destination you go to, there's a whole world there. And so with statistics, there's worlds all over the place. The question, does it have to be bivariate? It's just the easiest way to look at two different variables. We can talk about what to do with more multivariate analyses, what to do with some of that stuff later. At the very end of class, I'll talk about multivariate stuff. But we're not really going to do anything other than, I have a somewhat extensive publishing history, and I do a lot of bivariate correlation tables. I did a ton of analyses yesterday getting ready for ACSM, and every single one of them began with a bivariate correlation table to give me grounding, give me footing, let me see what the landscape looks like. It's sort of a map. Let's stick with fantasy. Every book, whether it's Lord of the Rings or whatever, begins with a big map. There's like a map on the first page of whatever it is, whatever book you're reading. It's Westeros, it's whatever. There's always like a map. The bivariate correlation table is that map. It is the map on the first page, and it tells you where you're going and where you're headed and what you can expect to find there. There isn't detail in the bivariate correlation table. You're not controlling for anything. It's just a crude map with upside down V's for mountains. I mean, it's not a detailed map. What gets published is a detailed land surveying of that environment. But what you do right when you start the statistics, what I always do is a bivariate correlation table and say, okay, what does this map look like? What variables move with what variables? What do we have in here? What relationships can I expect to find? Now, some of them are going to be spurious. Some of them are just random. That's why I'll put in like alphabet number and 989 number, where I just want to make sure we're not finding a bunch of weird spurious correlations. You expect to see, a significance that's terrible. With sex, a significance of 0.926, meaning there's nothing there. Now with a t-test, again, you're going to see that 0.926, but these values right here, these are the subsample mean and standard deviation. So those are the exact scores on the test for our men and women in this class. And then this significance tells you sort of a validity of the significance you report. So Levine's test for equality of variances, if this is above 0.05, arbitrary cutoff, but it's a reasonable one. I'll talk about what 0.05, where it came from, and its implication today. But you look at this top number over here. 0.926. That's the significance you would report. You could say like, well, this is insignificant. Let's look at the bottom number. But at that point, you're having some assumption issues. Now over here with the 95% confidence interval, what we're doing is this is inferential statistics. In the larger group of men and women who would be taking this class, is there going to be a difference? And so we're looking at the 95% confidence. We're 95% sure, the true difference between men and women, the true sort of t-test difference is going to be between these ranges, right? These two bookends, these two anchors, whatever you want to call them. Okay, getting into the regression. Now, the regression is going to be, you're going to run this a lot. And I added one additional variable here from the regression I showed you on Wednesday, the 989 number. What you'd expect to see is horrible significance, because this is it's random. You don't expect your 989 to predict your grade on the exam, and it doesn't. A p-value of 0.987, right? It's 98.7% chance you would have observed its effect or something more extreme than that by, if the null hypothesis were true. So the stuff you want to pay attention to, I highlighted. It's this stuff, right? So it's right here. It's the R squared. That means 35% of the variance in exams, the scatter. Some people got poorer grades than they were hoping for. Some people got better grades than not they were hoping for. Everyone hopes for 110%, but some people got really high grades and they're delighted with them. Some people were undelighted, whatever the opposite of delight is. They're furious, and there's scatter, there's variance, there's distribution of scores. R squared, what percentage of that scatter can we account for with this collection of predictors? In this case, these three predictors. If you were to add time spent studying and we find statistical significance, what does that really mean? So what that means is highlighted here. So this is the significance for the overall model. This is the overall model, okay? And these are the significances you really care about. These are the significances of individual variables. Remember, significance signifies. And so entering GPA, with each additional point of your GPA, you go from 2 to 3. That's a big jump, right? You go from 2 to 3. You go from 3.3 to 4.3, whatever you go from 2.3 to 3.3, 2.5 to 3.5, 3 to 4, right? A 1-point jump in GPA corresponds to a 9.3 percentage point jump in the exam. You go from 80 to 89.3. with a significance of 0.001. Now, what the significance means is there's a 0.1% chance that you would have observed an effect this big or bigger, this extreme or more extreme, of this magnitude or something more, greater, huger. This could be negative. It could be even more negative, right? So it's of a magnitude that's greater. It's not a more positive number. So there's a 99.9% chance that this is kind of validly escaping random, spurious, unmeaningful correlations. So the legitimate definition of this p-value, there is a 0.1% chance that you would have observed an effect this big, this extreme, or more extreme if the null hypothesis were true. Now, the null hypothesis is GPA and exam grade have nothing to do with each other. In a multiple linear regression, which is what this is, we have, again, univariate analysis. There's a single dependent variable, exam points, but there's three predictors here. So in a multiple linear regression, which means one dependent variable, but multiple predictors, people would call these independent variables. In regressions, people tend to refer them as predictors. Entering GPA, this value, this unstandardized beta, is holding constant duration spent on Canvas and your 989 number, but who cares? I put this in there to show it doesn't matter. This stuff seems to matter, right? So the duration spent studying has a marginal effect. With each additional hour you spent on Canvas, that doesn't mean studying, it just means you were logged in. With each additional hour spent on Canvas, this happens to your grade. It goes up, you go up, 0.16 percentage points. So go spend 10 hours studying and your grade goes up a tiny bit. But significant, now again, significance does not mean magnitude. Significance and magnitude have nothing to do with each other. Not nothing, they're related. The greater the magnitude, the more significant it's going to be statistically, but significance is not talking about magnitude. Beta is talking about magnitude. Beta is magnitude. Significance is statistical probability. You can have, just like this is a tiny magnitude with a pretty compelling significance. So that's the stuff you pay attention to. We'll talk more and more about the confidence intervals as we move along. But again, you get a bunch of data in this, but all you need to pay attention to are these particular variables. This is all you report. Now, the reason I don't, take these tests, the mean was 77, and the reason I'm not going to take them up to, 85% and every little complaint I honor is, okay, Joe DiMaggio, everyone knows his name. Once I announce Joe DiMaggio, his name, and Derek Jeter, I'm sure you have all heard of these players, baseball players, right? But these are famous for never arguing an ump call. Joe DiMaggio and Derek Jeter, they never argued a call. And so the reason I so seldom round people up and give people calls is to enter into life with dignity and respect and promise of productivity. Nobody argues an ump call. Now, the average NBA and MLB and NHL players who go into pro, their IQs are in the 2 digits, right? You see people arguing calls, and these are not bright people you want to model your academics and your behavior after. And what you want, if you want to be shown respect, you want a hard ump, a hard ref, a hard judge. That's a show of respect, right? So whenever I played high school baseball, and then I coached high school baseball, when I had an ump that was against me, the ball bounces to the plate and is strike, right? Like it bounced before it got to me. I felt complimented. Like, okay, my strike zone is, you throw it over the backstop and it's a strike, right? Fine. My strike zone is 10 feet in diameter. I'm still going to get on base. I'm still going to win. Like a 10-foot strike zone isn't going to stop me, right? It might stop the person who complains about everything, but that person isn't going anywhere in life, right? You want, like if it's basketball and they call a foul and you didn't even do anything. No. Yeah, I'll tell you what. Why don't you take 5 free throws, right? I'll just spot you 10 points at the start of the game. That's the person you want to be in life. That's the person who accomplishes an enormous amount. If you're familiar with Mario Kart, the person winning, the person in the lead, is not going to get the lightning bolts and the spiny shells, right? Those are the people who are in last place are getting all like the great items. And you want to be the person who only gets banana peels. This reference would make sense if you know Mario Kart. That's a show of respect. That means you're a stud, male or female. Ignore the definition of what stud means. And now there are some historical examples where it gets a little bit silly. You should look up the 1972 U.S. versus Russia, USSR, Olympic basketball. It was funny, right? That game was sort of funny. The refs are sort of bought out. It was one of the biggest upsets of basketball, Olympic basketball. The US lost to the USSR, and it was sort of hilarious. But the US totally deserved to lose. And anyone who says otherwise sort of has no idea how to behave in life and what dignity actually looks like. Because the US should have been winning by 60 points. Why did they allow a couple of bad ref calls to make them lose their game? Bananas have their advantages. That was a comment. That's true. You hang on to that banana behind you and everything but the spiny shell and the lightning. It stops. But the U.S. against the USSR, 1972, Google it. It's funny. It's funny, right? And it's a great example of bribe dumps and terrible refs. I get basketball. But there's no reason. It's 100% the U.S. players' fault that they lost that game. Anyone who blames the refs is a buffoon, right? Because the U.S. should have been up by like 63 points. This little 2-point stuff, that's insane. And you don't deserve to win if you're not winning by like 50 points. So never, call out an ump. Be complimented when the ump is hard on you, when the ref is hard on you. That's a show of respect. That means you're going somewhere in life. Okay, that's my pep talk is over. So we're here, September 25, right? We're going to get into the p-value. Remember, we're going to have lab 1. Nathaniel has already posted it. Start working on it whenever you want, but we're going to talk about it in class more and more. On October 9th, kind of coming up, lab 1 is due, and then we'll start talking about lab 2, those types of analyses. Research topic, the question at the start of class are the research topics. Is it individual or in groups? Depends if your project is an individual project or groups, but just be thoughtful, be creative, as much as you can. Consider gaps in the literature, be precise with your topic, get specific with it. October 16th, lab 2 is due, and then the exam is October 21st. All right, it's another mini boss that we have coming up before the final's relatively friendly boss. The reading, not too much reading for this entire block if you've decided to do it. This guy, like when I see pictures like this, I mean, it's obviously just clip art kind of picture, but anybody who takes pictures of themselves reading, I just assume is illiterate. Now, stuff like this, just as this is a new slide, but it's basically a recap sequence. This is basically a review where before you can analyze anything, you have to be familiar with the research that came before you. You don't want to show up and say, here's my research question. And I say, there are 75 articles that I have read on that subject that are phrased in the same way, and they came out in 1984. Now, this isn't, I'm not making fun of you if you do that. I did that when I was an undergrad. I presented a research, I actually had to go through the IRB legitimately at Willamette University up in Oregon, where I did my undergrad. We had to actually conduct a real study with IRB approval, and it took me like 2 months to get IRB approval, and I was in a panic. Human interventions and all this. And I tried to ask a research question, and my advisor sent me articles from the 80s. And he said, what is different about yours and this? And the answer was nothing, right? Because I was being lazy and I hadn't done the background reading. And he called me out on it, and I had to do better, right? And so when a professor calls you out on something, that should be inspiration, not to be like, oh, you asshole, right? But oh, I guess there's more that I can do in life. And that professor was an enormous springboard for me of I was lazy because high school was super easy. I didn't have to do anything. You wake up, you show up, and you get your grades, and wonderful. And then I get into college, and then I was hit really hard with this one professor, and it's changed my life. Right? I had this really difficult professor who held a standard, and you had to sort of get over that wall, right? You can't just stand and look at it and wait for someone else to lift you up. And so I managed to get over the wall, and my life was changed. So I'm holding you accountable, hoping something similar will happen to you. But we all begin with that. Let me do the laziest possible thing that I can do, because I did it too. I'm not above that. I'm above it now that someone called me out on it, and I'll probably call some of you out on it, but it comes from a place of professorial affection. Okay, so as you're identifying gaps in the literature, there's a couple different ways of doing that. Methods-driven research, easy. I like doing it because it's so easy to publish. It's a little bit uncreative, but it's super easy to publish. Now, I know the CEO of this company of Proteus, and so we were the first university. I flew out to New York, and I was in their promotional videos and stuff for their equipment before the equipment was officially released. As they were approaching investors, and then the equipment came out, and it's this amazing device that nothing else on the market replicates what this does, and it's this biomechanical machine and software that really calculates power parameters better than anything. And so we were able to negotiate, like, I'll help you out at the start, and just, give us one at cost, and let us be the first university in the world to have one, and all that happened. And so far, because we're the first university in the world to have one of these, now tons of professional baseball teams have them, tons of hospitals have them, like Dodgers have this. I mean, there's it's in the major leagues and stuff. But we had the first 16 abstracts ever published on it, work from our lab. That's methods research. Nothing like this ever existed. You do anything and it gets published. Now, hypothesis-driven research, this is based on ideas. You come up with a creative idea that nobody has had before, and you pursue it. Now, some creativity is unethical. There's a lot of studies that were done once upon a time that can never be done again. Look up the Stanley Milgram studies, where it's fake shocking of people. If you know, Nazi era, like the Nuremberg defense. I'm not going to ask you about any of this on the test. This is history and geopolitics and whatever. But how people say, "Oh, I'm just doing my job," and they're like killing people and stuff. Where that psychology comes from? The Stanley Milgram study was an attempt to figure that out. It's super unethical. It would never be approved today. You can't do it. Institutional review boards would have your career and free time as you get thrown in a cell. But or this guy is still a big name in research, but Martin Seligman, if you look up his work on real shocking of dogs, not fake shocking of people, but real shocking of dogs for learned helplessness. Can you teach dogs to be helpless? Yeah, they could have accomplished stuff on their own, but can you sort of condition their life so they assume helplessness and are just wastes on the world? Right? Yes, you can, but it's a horribly unethical, cruel procedure, and you can't do it anymore. And so there's, and I'm not going to ask about studies, these sorts of studies, but just to be aware, again, this is Hollywood set. I want you to look around and notice that there's a lot more than what we're talking about. Anywhere you look, there's a landscape. We're building a world, but we're focusing on the Shire, or focusing on whatever little hunk of Middle Earth. I hope Lord of the Rings makes sense to you. We're focusing on Tatooine. Let's make it about Star Wars. But so that's all I'm saying is the world of statistics, the world of research is huge. It's enormous. It's so vast, and we're focusing on particular things with acknowledgement of a wider world. But if you had no barriers, what would you do? What type of research would you do if there was no IRB, there was no institutional review board, IRB, if there's no governing agency, if there's nobody looking over your shoulder saying, can't do that? And that is a line of inquiry that you could pursue, a broad line, and you start sort of whittling it down, right, into a gap in the literature, a very specific type of question. If you're like, well, I want to see what dose of Tylenol, what the actual maximum dose is that doesn't kill people. Good luck getting that by a institutional review board, because Tylenol is the leading cause of liver toxicity in the US. But whatever the question, just come up with something and we can figure out a way of evaluating it. But you're going to have, ideally for this class, everyone's going to acquire publicly accessible or otherwise privately accessible to you existing databases, retrospective analyses. Let's look backward and run some regressions. Let's look backward in a case control scenario, or run some linear and logistic regressions and come up with a narrative, a statistically supported narrative. But do you have the equipment? Do you have the subjects accessible? Do you have the funds to finance it? In the history of this class, when people could do live studies, people kept trying to come up with these pharmacological studies. People will do this for a thesis. They'll come up to me and say, I want to do this pharmacological thing, not understanding that we teach pharmacoeconomics across the river, right, in the farm school. Bob Hallowell, that's the professor who teaches it, and he and I used to have barbecues together all the time, and he would tell me exactly how much it costs to run these pharmacological studies. And a reasonably priced one is you're looking at like we're getting into the billions of dollars here, and 5 years and $5 billion. I mean, it gets outrageous, the cost of these things, and you're not going to do that for a semester. So being realistic about what you can do throughout the semester. Now I'm going to go back and forth with recap, sequence, content, but it takes forever, right? It takes forever to really learn something, quote, inside and out. To learn the out, right? To learn the exoskeleton of something, just go read a meta-analysis, and you can sort of get the gist in a day. And that's all you have to do for this class. Get the gist in a day. But don't confuse yourself with being an expert in a field because you read one meta-analysis, because you'll go to a conference or you go into a conversation with somebody, a PhD in that field, and they'll look at you with such sorrow and sadness in their eyes. So we all have to be careful about how much of an ego we get after reading a single article. But the level of expectation for this class, if you can find a meta-analysis or a good systematic review, that's sufficient, right? That's not to learn the inside and out. It's just sort of to learn the surface, to learn the breadth of it, maybe not the depth. It's more than dipping your toe in, right? You're going calf deep in that body of water, in that lake.
Can I ask a quick question?
Yeah.
So when we give in our research question, we should have already looking at like one meta-analysis, and you'd give us feedback on whether that was sufficient or not, right?
Yeah, I will give you feedback. If you've looked, that's ideal. Now, if you have a research question worked out and it sort of doesn't appear in the literature and you're just like super creative and that hasn't been asked before, totally possible, then I can direct you into, you come up with a research question and I say, wonderful, let's look at relevant literature that's in a slightly different field. But we can make rational leaps where we can say, okay, we're not actually looking at, for like Proteus, let's look at video analysis software. We're the first people ever to publish on Proteus. So let's look at video analysis biomechanics and make some assumptions, and it's a logical leap to go from one biomechanical analysis to another, and so you may not find a nice meta-analysis or systematic review on your subject. You may come up with a research question ahead of time, but if you can come up with a meta-analysis, read it. They'll often just tell you at the end of, hey, here's what's really weak in the literature, here's what we don't know, here's what people should be exploring. At the end of a meta-analysis, you'll often encounter paragraphs that just say, here's what future researchers should look at. Those sentences usually appear. So they do a lot of the heavy lifting for you. You just have to sort of pick up their load at that point.
And if we ask a question where there's not a lot of data available, what do we do then? Like, how do we construct an experiment or a research with no, I mean, you know what I mean? Like, there's
Yeah,
no.
I do know what you mean. It's really individual because it depends on the nature of the question, what you do. But I can answer this from one question, the Pokemon study 2 years ago, whatever it was, Benson Lin and Emmeline Simone, and not a lot of published literature on Pokemon, and so they went to I don't know, fan boards and what other people were saying, and said, colloquially, here's what is described, here's what's said, here's what's believed. Are these things true? There are no statistical analyses, no comprehensive, unbiased approaches. People just love this foily, shiny thing, and this one's sparkly, and this one has cute eyes, and people make claims about them. But do we know if any of those claims are true? And so you can establish a dearth, an absence. You can establish a lack of knowledge and then move forward from there. But we'll talk in specific detail based on questions, how to approach a research question that hasn't been sufficiently undertaken in the past. We can talk more about that individually.
Okay, cool. Thanks.
Yeah. So again, this stuff like takes forever, but just remember study quality, right? A paper is not a paper. Just because it's published, that doesn't mean it's good. There are publications that are definitely regarded as much better than others, and we've talked a little bit about that. I'll talk a little bit more today. Remember that Michelle Maloney, wonderful, smart, super helpful. Do work before you go to her, right? Don't just hand her your load and say, your turn, right? So do as much as you can, get as far as you can. And then just like when you're browsing the internet, it is so hard to get a live person to help you. Go to Amazon and try to get an actual person to help you. You click around and there's FAQ pages, frequently asked questions, and they try to narrow down your question, or call some company that says electronic recording. Is your question this? Here's the answer. Is your question this? Here's the nobody wants to actually help you. And it's like, okay, your standard, easily accessible routes for information have all been used up and you still don't have an answer. Let me help. So let that be Michelle. Just get as far as you can. They say, oh, look, I've carried this load as far as I can. I don't know how to get across this fjord here. I'm sort of at an impasse. And that's when you go to Michelle, and she's wonderful and can really help you. Again, this is the page that would be most appropriate for our class. It says 279, but there is no 180 page. The 279 page is the graduate equivalent of this one. And some questions I haven't seen yet. How do I seem like those we were just talking about. So remember, Live Strong, Ask, horrible, right? Facebook, horrible. Twitter and Instagram, horrible. I mean, pretty much everything on there is false. Now, I like Wikipedia. I really like Wikipedia. Don't cite it. Get ideas there, and then go to their citations, look at the claim they make, scroll all the way down to their citation, and go to it. And you will find what is almost always, not always, you'll almost always find a peer-reviewed journal article that's making a claim in support of what was said in Wikipedia. Wikipedia is wonderful. People who say otherwise are sort of clinging to 10-year-old internet, right? Wikipedia is really good. I mean, people who are updating this have PhDs. And again, I said this earlier, but I would argue it's better than UpToDate, which is the super expensive physician source of information that they use, because I compared the two. Personally, I sat in front of the computer on topics I knew, and I compared UpToDate and Wikipedia, and I thought Wikipedia was better and more accurate and more up-to-date, and they understood the nature of science more, the nature of analyses. Google, great, it's fine. Just be careful, because you're going to get a billion findings and there aren't a billion valid findings. PubMed is going to be much better. Just remember, PubMed, I mean, since the 40s, just every valid thing that you're going to find on the internet, everything valid, is more than 20 million references, and they're all peer reviewed, and they do the sorting for you. Last lecture, I think I called it the major label of music, where they do this gradation for you, like a museum. You don't go to a museum and just everyone from town, all the locals have their stuff up. Right now, sometimes there'll be an exhibit with like the local kids, but you go to whatever museums, Natural History Museum, or the Metropolitan Museum of Art, or the Hagen down the road, and they decide what is art, and you just have to go look at it. It's the same thing, this curating. It's the same thing with PubMed. They do this curating for you. So you type in whatever. I typed in liquid puppies, and this came up. It's a bunch of like dog semen stuff. That's not what I was expecting. But 13 items that are somewhat related to liquid puppies. Fine. You move on, right? Click on them. First, read the title. And if the title is enticing, either it's just so weird you have to read the abstract, or this looks applicable. This looks like something I'm going to use. And then you move on to the abstract itself. This is the abstract. Now, this isn't about liquid puppies. This is about the addition of rye bran and pea fiber to pork meatballs. And if this is something you're researching, wonderful. Read the abstract. Oh, turns out that wasn't relevant. Fine, ignore it. If it is relevant, go to the full text links and see if you can get the full text. And again, just same thing. Start with abstracts, identify the relevant ones, then read the articles. Sometimes there's going to be a full text link over here. Sometimes there won't. You can get an interlibrary loan from Pacific. You can go to Pacific's library and get an interlibrary loan. It could take as much as a week, 10 days to get these things. So plan in advance. Okay, I got to do my research. The thing's due in 10 days. I'll start my research in 5 days. you're not going to get the journals you want if you wait until the last minute, because you'll receive the interlibrary loan a couple days after the project is due, and then you won't even have time. You don't have negative time to read. Annual reviews, Cochrane Library. Cochrane Library is just wonderful. If you can find a Cochrane review on something, that's the only thing you have to read for your subject. Now, you're not going to find a Cochrane review on every potential topic. It's on some, but it's not going to be on every topic. Annual reviews, whether it's ACSM or NSCA or whatever organization is likely to do an annual, or maybe every 3 or 4 years, something like that, an updated systematic review will come out. Tons of good journals. Remember, the easiest way to look up if a journal is valid is the Thomson Reuters impact factor. The higher the impact factor, the better the journal. There are arguments here. I say that as an absolute, and to a degree, I believe it as an absolute, but there's error here. There's a margin of error, and no algorithm is perfect. This just happens to be the algorithm I like, and they do a really good job. It's not perfect, right? So there's some journals that are amazing that have a lower impact factor than journals that just have this really high error rate and have higher impact factors. But impact factors are a really good way of noticing the quality of a journal. None of these journals have an impact factor, right? None of these ones. And so again, these are different from the last one. I'll scroll through with haste, the same haste I did in the last one, and these are all different from I put in the last. Again, during this class, I'll get 6 more of these invitations. For $400, publish in our journal, right? And this one welcomes you to the field of burns. Why do they think I publish in that field? This one's dental and oral health. I don't publish in the CD, Courtney D. That's not my name. And so all of these things, we just keep getting these solicitations. They're basically going door to door saying, will you please donate? Trying to get people to publish in their journal, and they're going to charge them, and that's how they make money. And if they can get real names to publish in their journal, A, they make money, and B, it gives them some sort of citation power, some credibility. Now, some of the correspondence I get in the mail is real, and it looks like these fake things. So you have been registered on the journal. This just came in my inbox. How do you filter these? I glance at them really quickly. It's a good question. How do I filter these? I glance at them quickly, and I've gotten pretty good at knowing which ones are fake. And if they're asking me to be a board member, or if they're informing me that I've become a board member, or if they're asking me to please submit my journal for X amount of dollars, and it'll be reviewed within a day and published within 7 days. That's not how it works. A good journal, I published 2 articles in pain medicine, and each one of them was in review for over a year and a half, going back and forth in the peer review process. Now it's a little bit longer than usual, but I've had some get accepted on the first take. I had one ever, accepted on the first day. And then I had one go back and forth a couple of times. It wasn't a year and a half, but it might have been 6 months or something. But you think 9 months is this time, something like that, of going back and forth with the peer reviewers. Now, I get stuff like this all the time, and I say yes to some of them. This is, will you please be a peer reviewer? But it says, dear Professor Dr. Courtney Jensen. I'm like, okay, what the hell? Come on. I start reading, and then I'm like, oh, I actually think this is real. Journal of Cachexia, Sarcopenia, and Muscle. And I'm pretty sure that one's real, so I go Google it to look it up, and it has an impact factor of 12.5. That is a massive journal. I mean, that's like world-renowned. If that's NBA, that's NBA All-Star team. That's a huge impact factor. And so, yes, of course, I'll go be a peer reviewer for this one, and I'll read whatever paper this is. It's about sarcopenia and muscle loss in older people and stuff. And so I'll go be a reviewer for if I decide the journal is good and I want to be involved in that process. But the question, how do you filter? It actually gets kind of hard, and I mostly just delete, and occasionally I'm like, oh wait, I think that one might be real, and I'll read it and look it up. And all you have to do is Google the journal and impact factor. And if you're having a hard time finding the impact factor, it doesn't have one. And sometimes they'll say like surrogate impact factor, which means we're scam likely. And we're from Omnix or something, which is the massive scam. And so they're just, the phishing with a PH, those sorts of predatory journals, and you can look up. It's a huge problem in science because it just misleads people. There's lots of good websites. Again, I would put Wikipedia on there. Most people wouldn't. So they, I don't know if you guys have ever seen this. Okay, so you know, she thinks she can run. She thinks she can beat Usain Bolt in the 100. Now, clearly, she just has no idea what she's talking about. I'm sure she's a sweetheart and she knows a lot about, you know, I don't know, being a beautician or like some cosmetic thing. Maybe she's an astrophysicist. I have no idea. But she certainly knows nothing about sprinting. She knows nothing about athletics. And she's talking like a pro. She's like, she knows all about this. And slow people are running. If you've ever seen the whole video, it gets funnier. And the only reason I bring that up is we all need to be cautious about what we don't know and the extent of what we do know. And I talked about Ben Tollerine at the end of, I think it was last lecture, where his point was this idea of assumed mastery, that he gambles and everyone thinks they're good at gambling because they won $100 once. Oh, I went to Vegas and I won $300. Yeah, that's the scam, right? We talked about that very early in the semester, which is why all of these buildings are 50 stories tall and are lined in platinum. Yeah, that's why. It's because they take your money by letting you have a little bit up front. I'm sure Ben does that too, right? He makes millions of dollars scamming people who think they know, scamming, outplaying people who think they know the game. I mean, this is what buys him houses in like 3 continents is people think they're good at things that they're not. Now, I am good at very few things in life. I'm pretty good at stats, right? I'm pretty good. I have a lot of publications. I'm very good at particular domains of it. I'm very good at the storytelling piece and translating particular things and the fundamentals of statistics. I'm very good at statisticians. There's like, if you go around campus, find, you know, Bill Heron, he's an economist. John Mayberry is a mathematician on campus. These people are better at stats than I am. And I quote Bill Heron here. I'm very good at particular domains, though, the storytelling piece, the writing piece. But I don't pretend I'm a master in things I have no mastery in, right? It's offensive to me in the end. I set myself up to be embarrassed in the future. I'm good at muscle physiology. I'm not that good at cardiovascular physiology. That's Van Ness's domain, right? Van Ness is the cardiovascular physiologist. He's technically a neuroscientist, is what his PhD is in, but he's a neural control over blood pressure responses, cardiac responses. And Van Ness doesn't pretend to be an expert in muscle physiology. I don't pretend to be an expert in cardiovascular physiology. We know what we're good at. And we qualify all of our statements outside of those domains, and we don't pretend to know, and we ask what other people would consider not dumb questions, but infantile or unlearned questions. You watch me sit in a class of something that I'm not particularly proficient in, and I ask the simplest questions in the class. I'll sit in there with undergrads. I'll once in a while, I don't do it now, but a couple of years ago was the last time I did it. I would just take Pacific courses, like with you guys, in subjects that I don't know, I'm not familiar with, something that's novel to me, because it helps. I'll learn a new field, and I ask the most simple questions in the class, and I have a PhD, right? So we have to be. It takes an amount of humility, and you just have to be humble about things if you want to actually, you know, amass money and whether it's wealth or esteem in something. So don't do the assumed mastery thing. Be aware of what you don't know. So then, you know, executive summaries, getting into this, you know, what is an executive summary? This is 10 of your points, chapter 3, page 42 in the book, 10 of your points. Explain what it is right here. It's a synopsis. It's a brief description, you just 1-page description of exactly what you're going to do. It's not due before your research question. Research question comes first. Here's your title right there. And then you follow up with who's the principal investigator and associated investigators. So everybody's going to do their own one of these, and they're going to list themselves as a principal investigator. Even if you're working with, let's say it's a group of 3, you would put yourself as number 1 and the other 2 people as just list them here. And then you move on to the executive summary part of it. And here's your subheadings. And this is just a bunch of Latin gibberish. But statement of the bigger problem. Here's the perspective. Here's the context. Here's the big picture. And then don't write a bunch of Latin gibberish over public health concern, blah, 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 blah. And then move on to the next thing, statement of what is known. remember the Donald Rumsfeld stuff, the known knowns, known unknowns, and unknown unknowns. So statement of what is known in the literature. You can get all of this out of a good meta-analysis. Previous literature informs us that this, and this are all true. And statement of what is unknown, right? The known unknowns. You're not going to have unknown unknowns, but you get 2 out of 3 Rumsfeld domains. Statement of what is unknown. So here's the gap in the literature that you fill. Although we know all of these things, what remains unclear, what limited data discuss, what has scarce representation in the literature, however you want to phrase it, that's what you say in what is unknown. Then you move on to your purpose statement, which just follows. It's a therefore, right? So here's what's known, here's what's unknown, thus we're doing this. We're filling that gap, we're plugging it up. And then here, what methods are we going to use? Obviously, it's not, again, Latin gibberish, but what methods is probably going to be independent samples, t-tests, some linear or logistic regressions, maybe a chi-squared in there. We'll talk about all of this stuff, and the labs will help you understand it better. And then the statement of the benefits. What do people gain from this? This is that consider the end user bit, where you want to, will the ACSM Research Methods book help us construct a project easier? Is this sort of a manual? It is, but it takes a little bit of reading of here's step-by-step project construction considerations. I tried to include a lot of the relevant parts in the slides, but there obviously is more detail. Again, to really abuse this analogy of world building. Like, we're not going to visit Mordor. So let me just say Mordor's here and there's a mountain and it's hot and it's red. Okay, let's get on to the stuff I'm going to describe. The book, has all Mordor descriptions in it. I'm really overdoing this analogy, but the answer is yes, the book is helpful, but it has its own little adventure, and it requires a lot of additional time to read through it, but it does help if you do want to get it. So statements of what would help the world. Consider the end user. Here's what we would be aiming toward. These data could help athletes perform better in this context. These data could help people sleep better at night. These data, whatever it is. And then the objectives and hypotheses, you just list those next. So it's not that hard. This is a 1-page summary, not 1 page with size 16 font, like triple spaced, but a 1-page summary. And with each individual section, you are very specific. You waste no words. Never waste a word. That's offensive to the reader. And I mean, think about going to a buffet. You don't fill up on you want to beat the house. You want to get your money's worth when going to a buffet. So you go get all the seafood and the expensive stuff. Okay, give me the unlimited sashimi. Don't fill it up with just plain rice. I don't want 4 pounds of sticky rice, right? I want all the yellowtail. You want to put all the good. You don't want to waste calories, waste words, because the reader is going to sit down and read this, and it's going to be me, and I'm going to be pissed if I have okay, that sentence should have been 6 words and it was half a page, and you communicated nothing with any of that. So clear, concise, and concrete. Make sure what you're saying is what I understand. The words that you used, I'm going to understand exactly as you understand them. And so the process of revision, we'll talk more and more about the process of revision. But my favorite writers, let's say 2 totally different domains. My favorite writer ever has been dead for a long time, but a couple of my favorite living writers would be David Sedaris, Santaland Diaries. Let's explore diabetes with owls, stuff like that. He writes these he'll revise 20 or 30 times before anyone sees it. Patrick Rothfuss has said he revises about 60 times before those words are seen by other people, even by his editor, right? And so Stephen King, in his book on writing, he talks about, I don't remember the exact number, but he talks about revising. It was like 5 times before his wife is even allowed to see those words, let alone his editor, let alone a reader, right? In the first drafts, Stephen King can't do it. David Sedaris, like everything he's ever written is a New York Times bestseller. And he can't he can't do a first draft or a second draft or a third draft or a fourth draft, right? It takes time and revision and revision and revision. So to get clear, to get concise, to be understandable, to write well, it just takes a bunch of revision. Writing is revising. That's all it is. Writing is not typing. Writing is just revise and revise and revise. That was Truman Capote. He wrote the book In Cold Blood. Brilliant book. But that's not writing, that's typing, was his line. That was his criticism of Jack Kerouac on the road. Not that good of a book. I think Truman Capote is right. So glossary is, hypothesis-driven research, methods-driven research, what an executive summary is. You're going to have to do an executive summary. Now remember, statistics, oh, can somebody be my timer? I have no idea what time it is. So statistics, we've talked about this before. This is in chapter 6. And statistics, coping with uncertainty. The world around you is uncertain, and we have to make sense of it. We have to make sense of it so that we can make better predictions in life. We can make better predictions. Our behaviors will follow. Success is more likely to occur if our behaviors are more success-oriented. How do we make more success-oriented behaviors? Make better predictions about exposures and outcomes. How do we do that? Statistics, science, right? We have to understand how these things work. Now, scatter, variance, just like variance in our grades, there's scatter everywhere you look. Whatever you're looking at, look at the sky outside. How hot is it? How much rain are we getting? Variables they vary. 15, thanks. And so moving into how do we make sense of all of that variance? I think everybody would be familiar with this brand of commercial.
2 tickets, $46. 2 hot dogs, 2 popcorns, 2 sodas, $27.
For everything else, there's MasterCard, right? That was from 1997 in the World Series. This is from 2001. This one's years later. Great, wonderful. For everything else, right, there's MasterCard. Now, it's a wonderful slogan. McCann Erickson, this advertising agency, they're like agency of the year. They sort of took over the world on these things. And if you just barely rephrase that, the McCann Erickson MasterCard, for everything else there's MasterCard, you can do it with a p-value, where it's like there are some things statistics can't describe. Very few, right? Very few things statistics can't describe, but there are some qualitative domains. There are some philosophical and hypothetical things. There are some things that statistics can't describe, right? For everything else, there's a p-value. And that is a reasonable way to look at statistics, to look at research methods, to look at science in general. So this is Steven Pinker down here. This is 1997 book. He has a ton of really good books. Language Instinct, Better Angels of Our Nature, How the Mind Works, this one. Those are only 3 I've done. I assume the rest of his are just as good as those ones. But in this book, he says, what are the chances that crop circles are created by aliens? That's not a matter of chance. That's not a matter of statistics. That's not a matter of math. Questions like that are not mathematical. Those are better left to Twitter and Instagram and Facebook and the National Enquirer. And the questions like that are not mathematical. That's not scientific. You can't use a p-value for that, for the odds of alien crop circles, or if it's just a bunch of like drunk Westerners mashing down the corn crops. But p-values are really useful for sort of everything else, right? Everything that is mathematical in nature. P-values cannot describe crop circles, right? But they can describe scientific inquiry. And people do p-values wrong. They do it incorrectly. And so you start to get articles like this. That's a really good one. A Dirty Dozen, 12 p-value misconceptions. It's just these ideas of what people are doing wrong with the p-value. In undergrad, most people teach it wrong. They say, this is the odds that it's chance. Like, what are the odds that this outcome is by chance alone? Because they don't want to do the hard work of saying, what does a p-value actually mean? Let's get into the nature of an experiment, what it's describing, what probability actually looks like. And we have to talk about what a null hypothesis is. And so people don't really say, well, it's the chances that it's by chance. It's the odds, it's the probability that it's by chance. And that's not what a p-value is doing. And I understand how we get there because that's an approximation. It's an incorrect approximation, but it's on the perimeter. Of what a p-value is talking about. Now, you don't need to know the early history of the p-value. Let's get into the 18th century, 1700s about, babies and boy-girl odds and whatever. Who cares? That's not interesting history. The first person to really introduce it is Karl Pearson. His original name was with a C. He loved himself some Karl Marx with a K, so he legally changed his name to be Karl Pearson with a K. Wonderful statistician, really abused by Fisher later in his life, but sort of foundational. Remember the Pearson correlation coefficient, the R value, the Pearson correlation coefficient in those bivariate correlation tables. That's Pearson of the correlation coefficient when we do those bivariate correlations. So he sort of introduced what we think of as a p-value, but Ronald Fisher, I would say he's smarter. That was a more functional brain than Einstein, if we're going to talk about mathematics. Everyone just loves Einstein because E equals mc squared is easy to say and nobody understands it. But be like, oh, Einstein, and it has a nice sound to it. Or like Ronald Fisher, that doesn't have the same sound to it. But this guy really invented statistics as we know it and introduced the p-value and the ubiquitous nature of it. And so Pearson and Fisher, add those two names to your roster of potential testable material. Those two names are likely to come up on a test, but he was in the jazz age, right? I mean, this is like F. Scott Fitzgerald is drunk and typing, Great Gatsby is coming out, and there's just, flappers all around. And that's when Fisher is doing his mathematics. Notice there's no computers. Computers sort of started to enter the world in like the 50s. And Ronald Fisher was just making shit up in his head. And it was so sound and so brilliant, and nobody had ever done this before. And he's like, oh, how do I make potatoes grow better? And let me go invent ANOVA. I mean, he was a super genius, and he introduced this idea of a p equals 0.05 threshold. But he says in the third person about himself. People wrote really weird and passive back then. There's active writing is what you want to do. We'll talk about that later. What is the difference between p-value and significance? Same thing. Good question. Same thing. Significance, p-value. Significance is the p-value. A p-value is significance. So they are the exact same thing. Personally, the writer prefers to set a low standard of significance at the 5% point. Okay, personally and prefers. These are his words, right, of a p-value equals 0.05. Okay, confidence intervals, I promise we'll get to soon, because there is a p-value associated with confidence intervals. It's a 95% confidence interval. And so it's a very related outcome. We'll talk about confidence intervals in more detail soon. That was another question in the sidebar for those who didn't see it. So personally, I prefer to set, right? That's from 1926 from Fisher. And today we consider it this absolute law. We choose a 5%, a p equals 0.05 as this line not in the sand, right? It is a line in the cement, right? It is a line in the earth, right? It is just Moses parts the water. It's like, here's the line, and it is absolute. That's what we consider Fisher's 5%. But he's like, a scientific fact, this is again Fisher's words, a scientific fact should be regarded as experimentally established only if a properly designed experiment rarely fails to give this level of significance. Again, he's sort of vague here. He's not drawing any the cement is wet and he's putting his line in, but he doesn't think that cement is going to dry in the way that it did, right? He would be probably horrified if it were a decree. And so it's a later development in statistics that says, it's called the frequentist movement, that says a p-value of 0.05, we're rejecting the null hypothesis. It falls in the rejection region, and our experiment is true. We state facts. It's a p-value of 0.04. We have facts to state. P-value of 0.06, we have trends to state. P-value of 0.1, No, we accept the null hypothesis. This study had no finding. That's not reality. And that's what Fisher would say is like, I never said these were absolutes. I said that it's a reason to retest. Now, everybody in statistics, you read any history of statistics, and it's like Fisher was a genius who almost single-handedly created the foundations for modern statistical science. Our understanding of the world sort of came from this guy's brain, our mathematical understanding of the world. Super, super genius and a massive asshole. So in character, he was, let us admit it, a difficult man. Among his wide circle of admirers, he accepted homage with fair grace. With most other people, he seemed to feel that his genius entitled him to more social indulgence than they were willing to concede. He was a huge asshole who just attacked everybody and said, yeah, I'm the only genius here. Let me have 50 kids because the rest of the world isn't smart enough to rear a brood. I better populate the world with my sperm because the rest of the world is unfit. That was literally, that was his position and sort of how he behaved and what his verbs that followed. But man, was that guy smart. He attacked everybody. He attacked Mendel with his P's. Like, no, Mendel was wrong. But like, Fisher had a point with all of that. There's a great book called The Lady Tasting Tea. It's on my bookshelf in the other room. It's a history of statistics. Every time I teach this class, I almost decide to use that as our textbook, and I never have. So that I teach the class this way as opposed to a narrative version of statistics, and let's learn stats through its history. But I do touch on little bits of history throughout because they are important. So a null hypothesis, nothing's going on. That's all it means. It depends on your research question. Your research might be, are these two groups different? Are men and women different? Are basketball players and volleyball players different in height or vertical jump? Are two groups different? That might be your research question. And so the null hypothesis would be, no, they're the same. Your question might be, does this therapeutic intervention, 5 minutes, thanks, does this supplement make you lose weight or gain weight or get stronger or something? And the answer might be, no, it doesn't, right? So the null hypothesis is that nothing happened, or there's no difference, or there's whatever it is, there's nothing going on. That's the null hypothesis. Now, that can be expressed in a number of ways, whether it's effect or difference or whatever. A type 1 error, like just vocabulary here, a type 1 error is there's nothing. There is in real life, there's nothing. The supplement is just a placebo. Whatever it is doesn't work. The exercise routine doesn't do anything. But statistically, mathematically, scientifically, you think you found something. You find what I keep calling a spurious correlation or random findings. So if you think like a hypochondriac, you're always noticing symptoms that aren't really there. Oh, I have a lump or whatever. Like, well, no, you don't. That's like your elbow or so. So if you're a hypochondriac or a friend or a family member that's a type 1 error. People thinking they've found something and there's nothing there. Type 1 error. Now it's a mathematical equivalent of being a hypochondriac. A type 2 error, The Lazy Detective is the name of the book. There is something going on. That supplement or that drug should have worked. That exercise prescription should have worked. There is a discernible difference between those groups. In real life, there's something real. There's something that you should have found. And statistically, whether by sampling error or your math or some other version of error or some confounding error in there somewhere, you didn't find it. That's a type 2 error. A type 2 error is you failed to find something that's actually there. A type 1 error is statistically you found a finding and it doesn't exist. You found something false. Those types of errors, just to make sure you know what those are. And what the p-value actually says, this will be the last slide, is what the p-value actually says is, if the null hypothesis is true, there's nothing going on, right? Null hypothesis, there's no finding to be had. Then you have a p-value percent chance that you would have found an effect as great as you found or greater, as massive or more massive is of the magnitude or a greater magnitude, either positive or negative, right? This is a weight loss supplement. We lost 10 pounds. Okay, if the p-value is 0.03, then if the null hypothesis is true, which means that weight loss supplement does nothing, it's just a placebo, there's only a 3% chance, that's what this is, right? A 3% chance that you would have observed at least 10 pounds of weight loss. If, again, if the null hypothesis is true, that's what a p-value actually means. And we will stop there. And if you guys have some questions about whatever, or if you just want to start your weekend, let me know. Anyone have anything good? We're going to type 2 errors again. Yes. Can I pull up the last 2 slides? Yes. All right, so right here, I think this is the slide that has everything that you're asking about. So again, we have our hypothesis. Let's say the experiment is creatine increases your bench press. Fine, that's our hypothesis. And we set a threshold of 10 pounds or something, of 10 pounds is meaningful. Earlier in the semester, we talked about what's actually meaningful. And as I was talking about confidence intervals, and physical therapists are often guilty of coming up with hilariously meaningless findings so they can say their treatment worked. We increased glenohumeral range of motion by 1 degree. What does that mean to the patient? Nothing. It means exactly nothing to every patient ever. There will never be a patient who has ever lived who would notice a degree, but success, right? So in the history of PT literature, you'll find a lot of these hilarious studies where they just come up with meaningless findings. Now, you want to have a real hypothesis. Creatine increases bench press by 10 pounds. 10 pounds is meaningful, okay? Or it could be vertical jump, it could be whatever. But for the sake of the example, we're saying bench press. The null hypothesis, creatine and bench press, nothing to do with each other. Take all the creatine you want, your bench press isn't going anywhere. So we have a hypothesis and a null hypothesis. We do an experiment. The experiment lasts 3 months. And at the end of 3 months, you retest your bench press. If you find that you have an increase in bench press. Oh, bench press went up by 11 pounds. But really it didn't. You just ran the experiment badly. That's a type 1 error. A type 1 error is you find something. You reject your null hypothesis. You reject it. You say, no, the null hypothesis, creatine and bench press have nothing to do with each other. You reject that null hypothesis because your p-value fell in the rejection range, just 0.05 or less. Ronald Fisher stuff. Now, that's a type 1 error if nothing's going on in real life, if creatine and bench press have nothing to do with each other. They do have something to do with each other, according to the bulk of statistics, but the bulk of experimentation, but that would be a type 1 error. Now, if creatine and bench press do have something to do with each other, they do, creatine does increase bench press, but your analysis, either sampling error, the people you enrolled were terrible exercisers and didn't adhere to the exercise prescription, or your testing instrument was bad, or people didn't adhere to the creatine protocol well. They kept forgetting to take it, or they exercised the day before the test. If there's some sort of error that prevented your experiment from showing its effect, from statistically demonstrating statistical significance, right? Demonstrating the effect of creatine on bench press. You failed to find it, but in real life there would be an effect. That's a type 2 error, right? Lazy detective. The detective, this is not Sherlock Holmes. This is whatever detective is horrible. I don't know that person exists in literature. And the type 1 error, the Mr. Bean or something, I don't know. A type 1 error would be the hypochondriac, right? Oh, we found something. No, you didn't. You just ran an experiment badly, right? You just have a bad experiment, and your significance is meaningless. And so you are rejecting the null hypothesis incorrectly, type 1 error. There's nothing there in real life, and your experiment says there is. Type 2 error is there really is something. There actually is something to be found. That medication really does cure that disease. Your experiment failed to show it. Type 2 error. Could a type 2 error be poor experiment that led to, do peer reviewers determine these errors? Your statistics, now peer reviewers are going to comment on it. Peer reviewers will comment on this stuff. There's a little box you always check that says, do you think, as you submit your peer review process, I just did one of these a few days ago, and actually I did it during our test. I wasn't proctoring all that well. I did a peer review while you were taking the test, and I had split my screen. And at the end, you click on a box that says, I do not think a statistical review is necessary, or I think a statistical review is necessary if you think the stats are bad. I sometimes click on it. Most people are bad at stats, you will find. I accepted this article with a bunch of caveats where I said, I don't like your statistics, but it's good enough. Now, I'm teaching you more advanced statistics in this class than most people use. I tend to suggest people use regressions. Most people, you'll find, don't know how to do that. They have no idea how to read them. They have no idea how to run them. They don't even know what context to run them in. By the end of this class, you will be able to do that, which you will be better than, your understanding of statistics will be better than 90% would be my ballpark estimate. 90% of all published manuscripts, those authors, you will know more about stats than they do at the end of this class. So I am sort of, my gatekeeping as a peer reviewer, I'm a little bit more nitpicky about stats, and it probably annoys the shit out of the people who are submitting their papers, and they get me as a peer reviewer who says and I say your stats are bad, and I always reject on stats, and they usually come back and fix what I say, and then I accept. I say I conditionally accept, contingent on correcting their stats. So let's end there, and on Monday, I'll talk more about null hypotheses, type 1 and type 2 errors, and I'll try to do context a little bit more broadly for some of this stuff, and then we'll start plowing forward in appropriate uses of a p-value, what it really means, and we'll go through these stats. Maybe I'll begin every lecture for a while with some statistics and say, here's what the p-value means in this particular study, right? Here's an output, whether it is a t-test or a regression, it's a chi-squared, it's a Pearson correlation coefficient, whatever it is, there's going to be a p-value, and I'll start doing this a lot more and more, and we'll have entire class periods where it's just outputs, and I'm just walking you through reading outputs to get you more and more comfortable with it, output after output after output, and I'll tell you what everything means. And so then when you encounter an output, it's familiar territory. You've heard this song before. You know how it goes. You can whistle along without even looking at the screen. And so that's where we'll get with stats. But right now, as I introduce a lot of new concepts and interpretations of p-values and these big messy outputs, it can seem a little bit potentially overwhelming, like there's a bunch of information. By the end of class, it's going to be super easy. Repetition of exposure. Not every lecture is going to be me talking really fast about new information. Some of them are just going to be really redundant, repetitive. Let's go through 50 regression analyses, one after the other. Just take your free throws. Let's stand at the free throw line and take 100 free throws. You're going to get the form of the free throw down in a hurry. So I promise there will be enough repetition for comfort coming soon. All right, let's get out of here. I'll see you guys.